Hi all, this is Priyadharshini, working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to look into the topic N-Queen's problem under backtracking. So the puzzle was originally proposed in 1848 by the chess player Max Bizel, and many years even Gauss, the famous mathematician, could not generalize the concept of N-Queen's problem. The first solution inventor was Franz Nauk for the N-Queen's problem. Then he has extended his research to N-Queen for arbitrary n by n size chessboard. So the input would be the positive integer. The task is to place N-Queen on n chessboard without satisfying the bounding condition. So let's see what is the definition. So N-Queen's problem definition is to place N-Queen on n by n chessboard so that no two queens attack each other. That is, the bounding function for the N-Queen's problem is no two queens should be on the same row, the same column or diagonally. If it happens, we have to report that this is impossible. So when we take to solve N-Queen's problem, first let us go step by step in a detailed manner. So when n is equal to 1, it is a trivial solution. We all know for n is equal to 1, it is 1 cross 1 chessboard. So only Qn is going to be placed. So it is a trivial solution. So when n is equal to 2 or n is equal to 3, we cannot find a solution. There is no solution exist. So directly we will jump to n is equal to 4. So it is this finding placing a n-queen on n by n chessboard with the bounding function is trivially a brute force approach. So when n is equal to 4, we have to take 4 cross 4 chessboard, that is 16 squares. So if it is 16 squares, it leads to 43,680 possible solutions. Same way when n is equal to 8, then it is 16,777,216 times. So time to find the first solution itself is 114 nodes. When n is equal to 12, it is 12 power 12. It takes nearly 260 nodes to find the first solution. So how to solve this N-Queen's problem? It can be solved by n numerous ways. It can use brute force, you can use local search, backtracking, divide and conquer, permutation, mathematical concepts or graph theory concepts to solve this N-Queen's problem. So let's see how backtracking works. So it is a 4 cross 4 matrix. So we have queens 1, 2, 3, 4, Q1, Q2, Q3, Q4. So first thing, we have to take Q1 and let's check by placing it in first row, first column. So when we place Q1 in first row, first column, then optimally the second queen should be placed in column 3, because there is no way for queen 2 in column 1 or column 2. So it should be placed in column 3 of row 2. So if we place column 3 of row 2, the queen 2, then we have to go with the depth first search, that is, we have to place queen 3. If we place queen 2 in 2, second row, third column, then there is no solution for queen 3. It has been since the bounding function does not allow queen 3 to be placed in any of the columns of Q3. So what shall we do is, we have to backtrack. So backtrack queen 2 to fourth column of row 2. So when we backtrack, then we can place queen 3 in second column of row 3. But when we go to queen 4, there is no way to place Q4. So what shall we do? We have to again backtrack to queen 1. So the final solution could be Q1 could be placed in Q2, 2 in place 3. So we can find a final solution by again backtracking queen 1 to second column. If we place queen 1 in second column, then queen 2 should be placed in fourth column. Thereby q3 will be placed in second column and then q4 will be placed in third column. So this is how the solution of the 4 queens problem will be given.